It is the week of May 11th. Wonderful geometry students. This week, we are doing composite figures, which is combining areas and shapes and generally finding the area of different shapes put together. I think this is going to be a pretty easy week for you, but you never know. It always starts off that way, but we get stuck later on. Here's an example. Two shapes put together. Looks like two rectangles. What is the area? Uh, this is an easy one. You can break it up into two sections, and you can find that break it into two rectangles. More than one way to do that. You could have drawn the line here, like they did. You could have drawn the line that way, or make it vertical. So you can find two different areas with the rectangles and put those together. All right, that's one example. I'm going to go through maybe three examples on the slides for part one. And part two, I'll get the whiteboard up and we'll go through one of the more complex problems that'll be a little bit more in depth. So that's one example, pretty easy. This one, kind of looks like a jack in the box almost, but it's a multi-shaped. We've got a triangle, we have a rectangle, and we have half a circle. And so we want to find the area of the whole thing. They give you enough clues that you can do that. Now, what I do, I drew this here. I really like to, I get a piece of scratch paper and I'm drawing all over the place. I literally will take them apart and look at them that way. So that helps me a lot. One strategy. So an example on this is that what do you need to find? You know the circle because you don't know the circle. That's what you got to find. You got to find this length here, which will be that length there. And so the strategies there are to find the triangle, the rectangle, and the circle. And if you did, when you go through that, this ends up being 9. When you do the Pythagorean theorem, right angle, 10.2 squared minus the difference here, I think it's 4.8 squared, you will get 9 for there, and that sets the whole thing up. So that's how that is going to work. That's an example right there of a little bit more complex. Here's another, I could check it out on this one. I had this discussion with Brother Bill the other day. This is actually a pentagon. It doesn't look like any pentagon we've ever seen, but it is a 5-sided quadrilateral. It's not a regular pentagon. Figure out the area of this. I don't know. I think what you could do is you could use the great red dotted line and break it into two parts. You could break this into a triangle and a rectangle and then go from there. Find the triangle. So you can see the missing point. You have one side. Looks like we need to find that side there. So you could do that. Practice that. You can draw that and practice that. It's in the book. That's one example of what we'll do also. The other example is to find areas by subtracting. So here we want to find the shaded area. So you find the area of the big rectangle, find the area of the triangle, and then you subtract to get the total. So the rectangle is straightforward here, 18 times 36. The triangle is pretty straightforward. It's going to be half of 16. 36 times half of 16. Height is 9. 1/2 of that's the area of the triangle is 1/2 times 36 times 9. Give you 162. You subtract, and that's going to happen. I like this one because it's like a basketball court. A little bit more tricky. Again, the shaded area is what we want to find. So you'll find the entire rectangle. Using the diameter, now you got to assume, of course, that 2 half circles will equal 1 circle. So you're good to go there, and you'll end up with, find the area of the rectangle. In this case, it would be 528. The area of the circle, pi radius squared, and you subtract them for 326. Okay. The next one, here we go. That's our mystery clue today. It's the Jack-in-the-Box. It's the classic Jack-in-the-Box toy. Now, there's a theme for this. Don't tell the algebra kids. You guys will remember this from last year. The classic Jack-in-the-Box toy starts in the box. You crank the handle, and the guy jumps up. And, of course, fast food chains hijack the whole thing. But this is the little song that goes with the Jack-in-the-Box. Da-da-da-da-da-da-da-da. If you remember your algebra days, That's coming up next week for them. So I'm setting them up with the old Jack in the Box, just like I set you guys up with the Pop-Up last week. So your clue for today is the Jack in the Box. So composite figures is basically finding the areas that you know, basically review and putting them all together. It can get complicated. This example right here, I spent about 45 minutes on because I made two classic mistakes. I'm going to give you this example on the whiteboard. We'll do this one together. But before I do that, copy that down right now. Make a circle. It's a circle, the diameter of 6, and a square inscribed in the middle. And find the area that's left over. I want you to try that and then click on video 2, part 2, and we'll go through that and see how well you did. It's a great little problem. So that's part 1, and Jack in the Box is the clue. So draw that out, and then we'll watch part 2.